Today we're going to do projectiles that are not launched horizontally, but ones that are launched from an angle. So again, like everything else in physics, you always have to measure everything from your frame of reference, which is your starting point. So here's our frame of reference. And what does that mean? That's because from here, our frame of reference is our sign convention. We're going to say up and to the right is positive. Now we're going to draw our picture. And you're going to, if you're given the initial velocity at an angle, you're going to write down that information. And again, once you have this, one of the things you're going to do is you can break that up into horizontal and vertical components, because with two-dimensional motion and projectile motion, we're always going to look at the horizontal and vertical separate from one another. Now, just some things that you have to be aware of. From here to here with this type of projectile, that's called the range. So, you know, like in golf, they say I'm going to the driving range. Well, this is called the range. So this horizontal displacement x is called the range. This is the maximum height. But if you notice at the picture, the maximum height is going to occur in half the time. So sometimes to make this easier, we're going to figure out the total time, and then we'll just divide by 2 to get the time that occurs halfway, or to get the maximum height. So here's steps for solving these problems. So number 1, you want to draw your picture. You need to establish your sign convention. You need to write out your given and what you want to find, but remember, you're going to divide it up. You're going to have x and y. You're going to break your initial velocity into horizontal and vertical components, if you can do that. You're going to apply all our same equations, but you're only going to apply them horizontally or vertically. So when we learn this equation, x is equal to VIT plus 1/2 AT squared, if I apply this vertically, it becomes y is equal to VIYT plus 1/2 GT squared. And if I apply this horizontally, it becomes x is equal to VIXT plus 1/2 AXT squared. But again, there's never, ever going to be a horizontal acceleration, so this is going to be 0. And you notice that I corrected the typos as I was going along, because for some reason the t's were forgotten here. All right, what I'm going to do today is I'm going to go step by step with the example problem that's in your notes that looks like this. So it says a golf ball is hit and leaves the tee with a velocity at 25 meters per second at 35 degrees with respect to the horizontal. What is the horizontal displacement of it? So first I'm going to draw my picture. Here's my vector. VI is 25. It's acting at 35 degrees. Now this just shows, this is kind of like how it's going to go. How far it goes is called the range, that's x. And if I want to find the maximum height, we can call this y. So where do I start? Well, I need to write my given. And remember, we're always going to break our givens up to x and y. So the first thing that I'm going to write on every problem is that ax is 0 and g is equal to negative 9.8. The next thing I'm going to do is, well, I have to find VIX and VIY. So I don't know those. So I'll write it in. I know VI, so I can find VIX and VIY, but one of these is not 0. So let's do that first. Here's VI. This is 25 meters per second. And now I'm going to find the components of that. So remember, those are perpendicular. So this is VIX. This is VIY. And this is my angle. So VIX is adjacent to the given angle, so this is going to be VI times cosine of 25 degrees. So it's going to be 25 times the cosine of 35. So VIX comes out to be 20.5 meters per second. So now in my given, I'm going to write 20.5 meters per second. VIY is opposite the given angle, so it's going to be VI sine of 25 with 35. Oh, the angle's 35. Whoops. So it's going to be 25 times the cosine of 35. And sometimes I catch the mistakes. So VIY is equal to 35, the cosine of 35 times 25, which ends up being 14.4. And now I'm going to put this here. Okay, now, what do I do next? Well, you have to look at the problem, and remember, I need three things. Well, this problem doesn't tell me anything else, so I've got a problem. Well, in this, let's think about this. This is where it starts. This is where it ends up. What's my vertical displacement? Well, my vertical displacement from here to here, I'm back where I ended up, so y is equal to 0. And that's the key to this problem. So now I have three things here, and now I know where to start. So I have three things here. Again, this is the total time that's in the air. So now I can say y is equal to VIYT plus 1/2 GT squared. Now this is 0, so 0 is equal to 14.4 T plus 1/2 negative 9.8 T squared. So one way we could do this is we could do the quadratic. But you know when we do the quadratic, so we could do it that way. And this isn't the only way to do it. We don't have to use this equation. We can actually use one of the other equations. So when we do it like this, or because we know we're only going to use the positive root, which don't do this in math class, I could factor out a t and have 0 is equal to 14.4 minus 4.9t. Put that on the other side. 4.9t is equal to 14.4. So t is equal to 14.4 divided by 4.9, which comes out to be 2.94, like 3 seconds. Now, what if they asked me, oh, it said, what's the horizontal displacement? So the horizontal displacement is x. So x is equal to VIXT plus 1/2 AXT squared. This is always 0. So now I substitute this in. X is equal to VIX 20.5 times 2.94 seconds. So x is equal to 60.3 meters. Whoops. So if they asked me, what's the maximum height? That's y. So the maximum height occurs in half the time. So whatever the 2.94 was, I would divide that by 2, and I could use this same equation here, and instead of the whole time, I substitute in half the time, and I could find this y. Again, you have to be careful with your signs, because remember, this is negative 9.8, so you have to be very careful with that. Now, there's other ways to do this. I don't have to use this equation. I could also use any of my other equations. You know how we have the equations like VF is equal to VI plus AT? So I could also apply this equation and say VFX is equal to VIX plus AXT, and then VFY is equal to VIY plus GT. So I could use this. I could also use the equations. It depends on what I'm given and what I want to find. I could use my other equations. VF squared is equal to VI squared plus 2AX, and then I could apply this equation both horizontally and vertically. So I'd get VFX squared is equal to VIX squared plus 2AXS. So that would disappear. And then when I have VFY squared is equal to VIY squared plus 2GY. When we look at the motion of a projectile, you'll see that, again, the horizontal component of the velocity stays the same, and it's just the vertical one that's going to change. So if we looked at this, here's my velocity vector like this, going across, and then it goes like this. So any one of these vectors, let's say here, if I broke this vector up, I'm going to have, this would be VFY, and this would be VFX. So this part is always going to be the same, and then the Y component, you see here, it's going to keep getting smaller until it's not there. Then it's going to start increasing again, but in the opposite direction. So again, understanding the conceptual part really helps you. You really need to draw a picture. When you do these problems, besides the diagram, you do everything horizontal and vertical. You keep it very simple, and you'll never make a mistake, and then you can easily solve these types of problems.